continue what we have been doing in the last videos. We stopped at Java 5 and this is Java 6. Let me clean this one. We don't need it anymore. We have seen it working. So I'll remove a few stuff like those. All right, we don't need it anymore. Of course, you keep them if you want them as an example. You can create a new project or something. All right. I'll remove all this now. So we start from the beginning because we have a new topic that is really, really important. Just to save time, I'll keep those because I'm going to be reading variables. Okay, here. All right, I'll just mark it because I don't need it now, like this. Okay, so it's commented out. Let's assume that I want to print number 1. Okay, I'll do print line like this. Print line number 1. So let's run it. Here is number 1 printed, right? Okay, I want to print 1 and 2. I'll print it this way. Okay, let's run it. Okay, here it is, printed. Assume that I want to print until number 5, so 1, 2, 3, 4, 5. So here, 3, 4, and 5. Here it is, you see the same statement. I actually repeated it 5 times. Now I decided to print the numbers until 10. I'll repeat this again here. Okay, so we're going to be doing it 6, 7, 8, 9, and 10. How about now I want to repeat this until 20,000. Now we have a problem. This tells you that this approach that I followed is definitely wrong. This is not the optimal, even though it will give you the right answer. Like, let's run it. Here it is. Numbers are printed from 1 to 10. All right. But definitely this is not the approach we should be following. And the example that would be, that proves it is, I ask you now to print me the numbers from 1 to 30,000. You cannot be doing this from 1 to 30,000. There is another way. How did I think about this? I said, okay, I'm going to print number 1. I'm going to print number 2, I'm going to print number 3, print number 4, and so on and so forth until print number 9 and print number 10. Is there any other way I can say this statement? Yes, there is. How I can say print the numbers from 1 to 10. So what I did is I described the problem to the computer, and the computer now is going to be doing it automatically. How? Using what we call loop. All right, using what we call loop. So instead of doing this, I'll start with a very simple loop. It's called while. While. Before I talk about the while, who is changing here? The numbers, right? It was 1, it became 2. It was 2, it became 3. It was 3, it became 4, and so on and so forth. So this means those numbers are changing. They are variable. They are variable. So I'll define a variable, I, and I'll put initial value is 0. Why? I explained it in the last, the previous video. Now, let's say that I will enter the maximum number you want to reach, starting from 0. Okay, so it's called x. And I define here I. You will see why. So if I start from I, I'll print I when it's 0, I'll print I when it's 1, I'll print I when it's 2, I'll print I when it's 3, so I will take those values. And I'll print I when it's 4, I'll print I when it's 5, until, when will I stop? When I is equal to x. I'll print it and then stop. So while I is less than or equal x, if you don't want to print x, then just less than, what will you be doing? Look at this. I'll take just one statement. I'll write it only once, but instead of 1, I'll write I. Okay. Let's see how this is going to be working. Here there is a big mistake. What? Look at this. I read the x here. Let's say 10. Initially I equals 0, and I'm saying while I is less than x, do whatever between the two brackets. But I will never change. I is always 0. Every time I print the I should increase the I by 1. You can also write it this way, by the way, I++. Either or, okay? So you can write it I equal I plus 1, or you can write it I++, okay? Of course, if you write it I++, you have to do the semicolon as well. Let's do the run, okay? Enter the maximum number. Let's say the maximum number is 15. Now, look, the numbers are printed until 15. Starting from 0. Why? Because I is initially 0. If you want to print it from 1, you give the initial value of the I to be 1. Let's run it again. Okay, and let's say until 12. Now you print all the numbers from 1 until 12. Okay, so here is, now let's say 100. Okay, I'll run it again. It will ask me about the number. I'll say 100 or 1,000. See, now you cannot write it 1,000 times. It will take you a lot of time. Here are the numbers. You go up, up, up. You know, you keep going, you will find the initial value of the I, which is 1. Okay, here it is. So what did we do here? I'm saying while I is less than x, do this. So it will keep doing whatever between the open bracket and closing bracket until this condition is no longer valid, which means I exceeds x. Okay, x is 1,000, so it printed all the values from 1 to 1,000. All right. Okay. How about this? Let's write a function that is called factorial. I'll tell you what a factorial is. Public integer factorial, and it takes a variable x. What is the factorial? Factorial are the numbers multiplied together. So factorial of 3 is 3 multiplied by 2 multiplied by 1. Factorial of 5 is 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Factorial of 10 is 10 multiplied by 9 multiplied by 8 multiplied by 7 until the 1. Factorial of 50 It's 50 multiplied by 49 multiplied by 48 until the 1, and so on and so forth. Okay. So I want to program this. This also needs a loop. So I write here result initially with 1. Why? Why 1? Because if you give it initially of 0, if you multiply anything with 0, it's a 0. Right? So the initial value, if you're going to use it in multiplication, it's a 1. And the initial value, if you're going to be using it in summation, is a 0. Okay? So here result equal 1, and then I'll get my variables. So I encode here, put it here. Okay. Oops, sorry. This is required. Here I'll return here result. Okay. Semicolon. So what do I need to do here? The result is initially 1. By the way, the factorial of 0 is also 1. Okay, I'll say if statement, if x equals 0, return 1. Why did I do it this way? Because it's a special case. Else, you don't need the else, by the way, because you're returning, but anyhow, let's go for the standard now, so I don't confuse you. All right. Else, I'll do this and then return the result. You can also say it differently. You can say something if x is greater than or equal 1. It actually would be even better. Okay, I'll show you how this exists, and then I'll show you the other code. Okay, and here I'm reading the x, and then I write here a message, which is the result, factorial of, and then here plus the number you read, x, and then I'll add is, plus then the result you get from the factorial. So I write here factorial of x. All right. Oh, sorry, I forgot a very important thing. It's a static. We're gonna resolve the static later on for the classes when the classes are not static. I will show you later, okay? But for now, we're gonna be adding it since we are writing all the code in the main. Okay, so here so enter the maximum number. Let's say the maximum is 5. By the way, the factorial of 5 is 120. Just, you know, so we can test our program, and then enter. In here we have a problem. 5 is 1. Oh, I forgot to do the equation, right? Let's do the equation here. So result here, result equal result multiplied by I. Okay, result equal result multiplied by I. So initially the result is 1. And the I is 1. 1 multiplied by 1 is 1. Now, I increase the I by 1. So I now is 2. The old result value is 1. So 1 multiplied by 2 is 2. Now the result is 2. And I increase the I by 1. So I now is 3. So the new result is 3 multiplied by 2. 2 is the old result value of the result. So it's 6, and so on and so forth. Let's continue. So result now is 6. Now I increased by 1, I is 4. So the new result is 6 multiplied by 4, that would be 24. and now I is 5. The new result is 24 multiplied by 5. That would be 120, which is the result that should have been there if I didn't forget this equation. Okay, let's now run it. Okay, let's write 5 again. So here is the result 120. Factorial of 5 is 120. Okay. All right. Now let's change something here. Let's write a better code. Okay. Why? You have the result here equal 1 anyways, right? So all you can say here, I'll remove this. Sorry, I'll put this here. And I'll say if x is greater than 0, if x is greater than 0, then do that. What if x is 0? What if x is 0? Then you will return, 1. And 1 is the factorial of 0. Because if x is 0, the whole thing will not execute. So it will directly go to return result. What is the initial value of the result? 1. The factorial of 0 is 1. To do a better code, of course, you can write something like this. You're going to execute if and only if x is greater than or equal 0. Why? Because negative numbers do not have factorial. Okay, here it is. I'll put this one outside. All right, here. And in this case, I'll put it with 0, because there's no such thing as factorial value of 0. So the minimum factorial value is actually 1, and then I'll put here the result equal 1. So this way, I'm making sure that the user didn't send me anything wrong. Didn't send me get the factorial of -7. No, minus doesn't have factorial. So I'll walk you through this again. Now 5, what, 120, let's run it again. What if it's a 0? Factorial of 0 is 1. Okay? So here is the function factorial. Let's go through the code again. From here, the main, I have a scanner, and I display this message to the user. I'm telling him enter the maximum number, okay? And then I read that number from the scanner as an integer. So that's why I'm saying scanner.nextInt. I return the value to the x, and then I call the function factorial x. I pass x to the factorial, the function, the method, and the result of this is being displayed. You can do it in 2 steps if you want, like this. If this confuses you, int v equal factorial, okay, and then here you display the v. You can do it this way, but I find it easier to write, replace the v with the value of the v, which is the factorial. Again, what is the plus? Maybe I didn't talk about it. You're making a concatenation. You're taking those and making them as one big string. So you're adding x to this. How will you add it? Add it as a string. So factorial of, it's going to be, let's assume x equals 5. So factorial of 5 is, and then 120. You're making it as one big string like the one you see here. Okay. Then you call the function. What does the function do? It puts the result equals 0. If x is greater than or equal 0, you put result equal 1, and then you put I equal 1, initial values. The result is the one that will have the value of the factorial. Int I is a variable that I will increase each and every iteration. Why? Because I have to do it and multiply 1 and then 2 and then 3 and so on. What if you want to do it in the opposite direction? Put I equal x initially, and then you keep descending it. I'll show you later on. Okay, so that's how it is. Let's run it one more time. Here, let's say you want the factorial of 10. The factorial of 10. Here is the big number, 362, whatever that number is. It's actually 3,628,800. If you don't believe me, you can actually try it on the calculator. Now, can we do it differently? Now, here we're multiplying, let's 5, so 1 multiplied by 2 multiplied by 3, 4 and 5. Can we do it 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1? Absolutely yes. How? Look at the changes I'm going to be doing. I'll put the I equal x initially. I is initially x, and then here while, I'll say while I is greater than 0. You can put or equal 0. It will not make any difference in the result. Why? Because the factorial of 0 is 1. Okay, and then I say result equal result multiplied by I. Let's better do it with here. Okay, I equal I minus 1. Okay. Y is minus 1 because it's 4, 5, and then 4, and then 3, and then 2, and then 1. So it's the opposite direction now. Let's run it again. So enter the number. Now, if I do it 5, it should give you 120. Let's see why it's a 0. The result is 1. 5. Oh, because I multiplied by 0. Sorry. Okay, here. Is greater than 0. Let's run it. Okay, and then we have the 5 here, 120. Okay, so you can multiply 1, 2, 3, 4, 5, or 5, 4, 3, 2, 1. It doesn't really make any difference. I'll finish the video here, and then I'll continue with the coming video, so it doesn't go very lengthy.